Welcome to The Explainer. Today we're going to talk about something that is basically a superpower for any programmer: design patterns. Seriously, these are a total game changer for writing cleaner, smarter code. So if you're ready to level up your skills, you are in exactly the right place.
Okay, so to really get into this, let's start with a feeling. A feeling I'm pretty sure every single one of us has had as a developer. You know the one I'm talking about, right? You're staring down a problem, and you just have this little voice in your head saying, "There is no way I'm the first person to deal with this." You start building a solution from the ground up, but the whole time it just feels like you're reinventing the wheel.
Well, that's exactly what design patterns are for. They're the collected wisdom of all the experienced developers who've come before us. Think of them less like a chunk of code you can copy and paste, and more like a blueprint or a recipe. They're these proven, battle-tested solutions to really common problems. And you know what else is great? They give us all a shared language. When you can say to your team, "Hey, let's use a facade here," everyone immediately gets what you mean. It makes talking about complex stuff so much easier.
All right, so let's make this less abstract. Let's jump into our first example. It's called the adapter pattern, and it solves a super common problem: incompatibility. So, picture this. You've got two pieces of code, and both of them are great. They do their jobs perfectly. The only problem is, they don't speak the same language. The way you interact with one is totally different from how you interact with the other. Their interfaces just don't line up.
The absolute best way to think about this is with a real-world example we've all run into. You're traveling, right? Your phone charger is perfect, the wall socket in your hotel is perfect, but they don't fit together. So what do? You grab a travel adapter. It's that little piece that sits right in the middle and makes everything just work.
And in our code, it works the exact same way. The part of your code making the request, we'll call it the client, talks to the adapter using a language it understands. The adapter then does that translation on the fly and passes the message along to the other object in a way it can understand. It's just a seamless little go-between.
And this is where it gets really powerful. This translation isn't just some simple one-to-one thing. An adapter can do all sorts of work for you. It can convert data from one format to another, it can shuffle the order of arguments, call a totally different method name, or even fill in some missing details with default values. It's just incredibly flexible.
Okay, here's a quick but really important point. It's easy to mix up the adapter with a similar pattern called the decorator. So let's clear that up. An adapter changes an object's interface. It's all about making two incompatible things work together. A decorator, on the other hand, keeps the same interface but adds new features on top of the original object. Think of it like wrapping a present. The gift inside doesn't change, but now it has shiny paper and a bow. In code, that could be like adding logging to a function without ever touching the original function itself.
Okay, so we've got a handle on fixing incompatibility. Now let's switch gears and tackle a totally different kind of problem: just overwhelming complexity. And for that, we have the facade pattern.
Oh man, we have all been there. You import some super powerful library to do just one simple thing, and suddenly you're buried. You've got to learn a dozen different classes, figure out this whole complicated setup process, manage all these dependencies. It's powerful, yeah, but it's a huge headache. I mean, take a library like Plant UML. To just get a simple diagram out of it, you might need to install GraphViz, make sure you have the right version of Java, juggle a bunch of jar files, create configuration objects, deal with data parsers, all of this before you've even started. The amount of stuff you have to keep in your head is just immense. And this is where the facade pattern is just beautiful. It's such an elegant solution. You create a single, simple interface that stands in front of that entire messy system. So instead of you having to deal with 10 different things, you just talk to this one facade. It takes care of all the complicated interactions behind the scenes for you. And this is huge for good software design because it separates your code from all that messy internal stuff. If the library gets a massive update, maybe you only have to change your facade instead of 100 different places throughout your code.
So, we've looked at how to connect things that don't fit and how to simplify things that are way too complicated. But, so what? Why does any of this actually matter in your day-to-day coding?
Here is the real takeaway. Learning design patterns isn't just some academic exercise. It's about building your own personal toolkit as a developer. You get the shared language with other coders, and you have these elegant, proven solutions ready to go. And what does that mean? It means your code is cleaner, it's easier to change, and it's way more robust. That translates to less time fighting bugs, an easier time for new people joining your team, and a code base that can actually evolve without falling apart.
So I want to leave you with this one question. Think about the code that you're working on right now. Is there a place where things are just too complex?
Or are there two classes that you just wish would talk to each other properly? Think about it. Which reoccurring headache could a pattern like the adapter or the facade solve for you today?